a second example here for you guys. Sorry about the weird cutoff on the last one. I wanted to like take a minute and actually figure out what I was going to do. So, and I accidentally started to start this. So I'm sorry. Okay. So anyways, so in example 2, we're finding this value of this integral. We have a definite integral right here. Okay. We have limits of integration. So again, we have a composite function. Okay. So we have stuff in our denominator, and everything in our denominator is raised to the first power, okay? So we are going to do a natural log, and inside of this denominator is the e to the 2x plus 1. So our u, oh, what am I doing? And I don't have white out anymore. I used it all. Is going to be e to the 2x plus 1, okay? I used a different color this time. Maybe you guys can see. We use some pink for our u, okay? And that's much better. So this means that our du is going to be 2 e to the 2x dx. Okay. All right. So now notice the stuff with x's that we still have yet to replace is right here. Okay. But the issue is this 2. Okay. So we need to get rid of the 2 in order to be able to exactly replace the green stuff. In order to make the 2 turn into a 1, which is the coefficient of this e to the 2x, we have to multiply the entire equation by 1/2. So I'm going to have 1/2 du equals e to the 2x dx. Okay, now this exactly replaces what's green in the function, and this piece right here is what's going to replace it. Okay, so the goal is to get the stuff with the dx on the right to match with the stuff that has the extra stuff with the x and the dx in my function. Okay, so now I'm going to replace everything in my function, 0, 5. I'm going to do what I did before, 1/2, 1 over u, and then du. Okay, so the things I'm sticking back in are this guy to replace this piece of pink, and this guy right here to replace this green stuff, okay? Now I'm multiplying all 3 of these things together because these 3 things were all multiplied together, okay? So I have 1 over u multiplied by the 1/2 and the du, okay? Because the 1 over this stuff was multiplied by both of these green pieces, okay? So now I can rewrite this kind of like I did before. I'm going to have 1/2 integral 0, 5, 1 over u du, okay? And I want to go ahead and actually integrate, okay? Again, the process to get to integrating is much longer than actual integration. So our integration is going to be 1/2 times the natural log of u plus c from 0 to 5. Okay, this time we're doing a definite integral. We didn't have any extra information because the c is just going to go away. We don't care what that c is, okay? To figure this out, we would do the upper limit first. Oh, nope, we're not done because we need to sub our u back in. I'm very sorry about that. So we're going to have 1/2 times the natural log. Our u was equal to e to the 2x plus 1 plus c from 0 to 5. Also, I am not going to care too much if this plus c just goes away. Okay? If you like don't write it, I won't take off points. It'll be fine. Because we can just assume with definite integrals that that's just not going to be there. Okay? So now I need to sub in my upper limit first. So I'll have 1/2 times the natural log of e to the 10 plus 1, and then plus c. And then I'll have minus 1/2 times the natural log of e to the 0 plus 1 plus c. Ooh, gross. I'm very sorry. That's a plus c at the end. Okay, now just like before, our plus c's are going to cancel out. Okay, and I'm going to go ahead and simplify all my e stuff. Okay, so I'm going to have 1/2 times the natural log of e to the 10 plus 1 minus 1/2 times the natural log of e to the 0 is 1, so this is just going to be the natural log of 2. Okay. Now clearly this is super gross. So there are two options you can do. At basically back at this point right here, or at the very beginning, you could have skipped the algebra, typed everything into your calculator like this, and then you could do second calc, go down to number 7, click enter, give your lower limit as 0, your upper limit is 5, and it'll go ahead and calculate that for you as 4.65. This is about 4.65. You could confirm this by actually typing all this into your calculator. So we would have 0.5 times the natural log of e to the 10 plus 1. Also, I'm pretty sure that you could simplify this a little bit more, but then you have this natural log of 2. So it's going to be something irrational no matter what. And we get the same exact answer. Okay, so either way is fine. If this were calculator inactive for some reason, like just leave it here. I don't care. Maybe factor out the 1/2 or something, but I'm not gonna. Or you could use natural log properties to combine all the natural log stuff, but I'm not gonna be a stickler about that. And then if it's calculator active, obviously, just sub it in your calculator way back here, or I guess even here, and just integrate. Okay, but that is the algebraic process. The actual answer is a bit more complicated. Hopefully these two examples answer some more of your questions. I tried to be more specific with like U's and DU's, and I felt like this incorporated a lot of the other functions that we've used. If you have questions about this particular DU right here, the only thing I think I didn't really explain was that we use the chain rule right here. The derivative of e to the 2x is e to the 2x always, but we have to multiply by this derivative. The derivative of 2x is 2. So we put our 2 up front right there. Okay, so I guess send me a remind or something if you have questions. Good luck today. You guys are doing amazing and I'm super proud of you. So thanks guys.